NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math tutorial, where we'll solve an algebraic expression problem. We'll solve this step by step so you can understand the process clearly. Let's look at our problem. We have three expressions. A equals 5x to the power of 5 minus 1, b equals 2x to the power of 5 minus 3, and c equals x to the power of 5 divided by 3 minus 4. We need to calculate a minus 2b minus 3c. Let's start by writing out the expression a minus 2b minus 3c. For step 2, let's substitute the values of a, b, and c into our expression. A is 5x to the power of 5 minus 1. 2b is 2 times the quantity 2x to the power of 5 minus 3. 3c is 3 times the quantity x to the power of 5 over 3 minus 4. Step 3, we'll distribute the multipliers. For the term with b, we multiply 2 by each term inside the parentheses. 2 times 2x to the power of 5 equals 4x to the power of 5. 2 times negative 3 equals negative 6. For the term with c, we multiply 3 by each term inside the parentheses. 3 times x to the power of 5 over 3 equals x to the power of 5. 3 times negative 4 equals negative 12. Step 4, let's rearrange and combine like terms. First, let's group the terms with x to the power of 5 together. We have 5x to the power of 5 minus 4x to the power of 5 minus x to the power of 5. Next, let's group the constant terms. We have negative 1 plus 6 plus 12. This gives us 5x to the power of 5 minus 4x to the power of 5 minus x to the power of 5, plus negative 1 plus 6 plus 12. Step 5, let's combine like terms. For the terms with x to the power of 5, we get 5 minus 4 minus 1, which equals 0. For the constant terms, we get negative 1 plus 6 plus 12, which equals 17. So we have 0 plus 17, which is 17. Step 6, let's simplify to get our final result. 0 times x to the power of 5 is 0, so we're left with just 17. Let's start with an example. We have two polynomials, a equals 5x squared minus 2x plus 3, and b equals x squared minus 3x minus 1. We'll perform two operations. First, we'll calculate a minus b, and then we'll calculate b minus a. Let's start with calculating a minus b. First, we'll substitute the polynomials into the operation. A minus b becomes 5x squared minus 2x plus 3 minus x squared minus 3x minus 1. Subtracting a polynomial means we need to subtract each term. So we'll rewrite this as 5x squared minus 2x plus 3 plus negative x squared plus 3x plus 1. Now, we'll group like terms. For the x squared terms, we have 5x squared minus x squared, which gives us 4x squared. For the x terms, we have negative 2x plus 3x, which equals x. For the constants, we have 3 plus 1, which equals 4. Therefore, a minus b equals 4x squared plus x plus 4. Now, let's calculate b minus a. Similar to before, we'll start by substituting the polynomials. b minus a becomes x squared minus 3x minus 1 minus 5x squared minus 2x plus 3. Just like before, subtracting a polynomial means adding its negative, so we get x squared minus 3x minus 1 plus negative 5x squared plus 2x minus 3. Now let's group like terms. For the x squared terms, we have x squared plus negative 5x squared, which equals negative 4x squared. For the x terms, we have negative 3x plus 2x, which equals negative x. For the constants, we have negative 1 minus 3, which equals negative 4. Therefore, b minus a equals negative 4x squared minus x minus 4. Let's observe an interesting relationship between a minus b and b minus a. We found that a minus b equals 4x squared plus x plus 4, while b minus a equals negative 4x squared minus x minus 4. Notice that b minus a is the negative of a minus b. This is a general property of subtraction. b minus a equals negative a minus b, or equivalently, b minus a equals negative 1 times a minus b. This applies to numbers, polynomials, and many other mathematical objects. Let's verify this property with our results. Negative 1 times a minus b equals negative 1 times 4x squared plus x plus 4, which equals negative 4x squared minus x minus 4. This matches our calculation for b minus a, confirming the property. We're given that a equals 2/3 x minus 1/2 y minus 1, and b equals 4x minus 2y plus 6. We need to calculate the expression, 6a minus 1/2 b plus 9. Let's start solving this problem step by step. Let's start by substituting the values of a and b into our expression. We'll apply the substitution rule, which states that we can replace variables with their equivalent expressions. Our expression is 6a minus 1/2 b plus 9. First, we substitute a with 2/3 x minus 1/2 y minus 1. Then, we substitute b with 4x minus 2y plus 6. This gives us 6 times the quantity 2/3 x minus 1/2 y minus 1 minus 1/2 times the quantity 4x minus 2 y plus 6 plus 9. Now, let's apply the distributive property to simplify our expression. The distributive property states that a times the quantity b plus c equals a times b plus a times c. Let's distribute the coefficients. First, we'll distribute 6 to each term inside the first parentheses. 6 times 2/3 x equals 4x, 6 times negative 1/2 y equals negative 3y. 6 times negative 1 equals negative 6. Next, we'll distribute negative 1/2 to each term inside the second parentheses. Negative 1/2 times 4x equals negative 2x. Negative 1/2 times negative 2, y equals positive y. Negative 1/2 times 6 equals negative 3. Our expression now becomes 4x minus 3, y minus 6 minus 2x plus y minus 3 plus 9. Now, let's combine like terms to simplify our expression further. The rule for combining like terms states that we can add or subtract the coefficients of terms with the same variables. First, let's group like terms together. We have 4x minus 2x, which equals 2x. We have negative 3y plus y, which equals negative 2y. And we have negative 6 minus 3 plus 9, which equals 0. Therefore, our final answer is 2x minus 2y, which can be written as 2 times the quantity x minus y. We've successfully calculated the expression 6a minus 1/2 b plus 9. Let's look at our example. We are given the following expressions. A equals 6a minus 2b minus 4ab, and b equals 1/3 a minus 2/3 b minus 2/3 ab. We need to calculate the value of a over 2 minus 3b. Let's start by substituting the expressions for a and b into our target expression. We have a over 2 minus 3b. First, let's focus on a over 2. Now, let's simplify a over 2. We divide each term in a by 2. Next, let's focus on negative 3b. We need to distribute the negative 3 to each term inside the parentheses. Now, let's simplify each term within the distribution. 3 times 1/3 equals a, 3 times 2/3 b equals 2b, and 3 times 2/3 ab equals 2ab. Now, let's combine like terms. We have 3a minus a, which gives us 2a. We have negative b plus 2b, which gives us b, and we have negative 2ab plus 2ab, which cancels plus 2b, which gives us b, and we have negative 2ab plus 2ab, which cancels out to 0. Therefore, our final answer is 2a plus b. Let's verify our answer by checking back with the original expressions. We had a equals 6a minus 2b minus 4ab, and b equals 1/3 a minus 2/3 b minus 2/3 ab. When we evaluate a over 2 minus 3b, we get 2a plus b, which matches our solution. Let's look at an example where we need to find the difference between two algebraic expressions. First, let's substitute the expressions for a and b into our target expression a minus b. Next, we need to distribute the negative sign to the terms inside the second parenthesis. When we distribute a negative sign, we change the sign of each term inside the parenthesis. Now, let's group like terms. We'll group the x squared terms together, the x terms together, and the constant terms together. Let's simplify each group of terms. Negative 2x squared plus negative 3x squared gives us negative 5x squared. 4x remains as 4x. And 1 plus negative 1 equals 0. For our final step, we can remove the 0 term, since adding 0 doesn't change the value of our expression. Let's start with an example. We have two functions, a and b. A equals 1 minus 2x squared, and b equals 3x squared minus 4x plus 1. We need to calculate a minus b and a plus b. Let's first calculate a minus b. We'll start by substituting the given expressions for a and b we have a minus b equals the expression for a, which is 1 minus 2x squared, minus the expression for b, which is 3x squared minus 4x plus 1. Notice that we place the entire expression for b in parentheses because we're subtracting it. Now, we need to expand the expression by removing the parentheses. When we remove the second set of parentheses, we need to distribute the negative sign to all terms inside. So 1 minus 2x squared minus 3x squared plus 4x minus 1. We're essentially changing the sign of each term inside the second parentheses. Next, we'll combine like terms to simplify our expression. First, let's group the x squared terms together. We have negative 2x squared minus 3x squared, which gives us negative 5x squared. Then we have the terms with x, which is just positive 4x. Finally, we have the constant terms, 1 minus 1, which equals 0. Since adding 0 doesn't change the value of an expression, we can further simplify our answer. So, a minus b equals negative 5x squared plus 4x. Now, let's calculate a plus b. Again, we'll start by substituting the expressions for a and b. A plus b equals 1 minus 2x squared plus 3x squared minus 4x plus 1. Notice that since we're adding b, we don't need to change the signs of its terms. Now, let's combine like terms again to simplify our expression. For the x squared terms, we have negative 2x squared plus 3x squared, which gives us x squared. The term with x is negative 4x. And for the constant terms, we have 1 plus 1, which equals 2. So, our final answer for a plus b is x squared minus 4x plus 2. Let's look at our example. We need to sum the two expressions, negative 4x yz plus x squared yz cubed plus 4x, and 3x squared yz cubed plus 2x yz plus 3 y minus x squared yz. Let's start solving this problem step by step. Step 1. We first write out the full sum by combining both expressions. We have negative 4x yz plus x squared yz cubed plus 4x plus 3x squared yz cubed plus 2x yz plus 3 y minus x squared yz. Step 2. Now we'll group like terms together. Like terms have the same variables with the same powers. We have x squared yz cubed terms x squared yz cubed from the first expression and 3x squared yz cubed from the second expression. Next, we have xyz terms, negative 4x yz from the first expression and 2x yz from the second expression. We also have an x squared yz term, minus x squared yz from the second expression. There's an x term, plus 4x from the first expression. And finally, a y term, plus 3y from the second expression. Step 3. Now we can combine the coefficients of like terms. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.